All right, good morning, guys. This is 9.2 quadratic functions. And a quadratic function is basically a parabola, so it's a U shape. And remember, a parabola can go down or it can go up, just kind of depends on the problem. That all depends on your A value. If your A value is positive, it goes up. If it's negative, it goes down. And then there's narrow and wide graphs. So all that together, and just a couple of things on how to graph them today. To graph them, you're going to have to first find your axis of symmetry. Your AOS, or your axis of symmetry, is found by the formula minus B over 2A. And make sure you get that on the left-hand side of your notes. Now, if I page back a little bit here and show you that in your objective, it goes in order as long as it's in standard form, A, and then B, and then C. It's the coefficient, so it's the number in front of x squared, not x squared. And that's going to be your A, B, and C. Okay, and then we'll get to one here. Go ahead and put this guy into your notes. So the first thing we're going to find is the axis of symmetry, which is the formula minus B over 2A. Now I'm going to have some open spots here. That represents the B and the A. Now remember, it goes in order. This is your A, this is your B, and this is your C. Your B in this problem is -6. Now from the original formula, minus B over 2A, there's a negative here to start off with, and then there's another negative on that 6. So in other words, two negatives is going to equal a positive 6 over. And our A value is the number in front of x squared, which is a 1. Okay, and we simplify this down here. 6 over 2 reduces to 3. So in other words, your axis of symmetry is the equation x equals 3. And that's going to be the dead center of your graph, guys. Okay, once you know that the center of your graph is located at 3, here's what you do. Oops, daisy. I'm going to try to get rid of that real quick here and undo it. Okay, so I'm trying to go back. Okay, so I'll try to get this reduced down a little bit here. Okay, now your vertex is found by getting a coordinate, and the coordinate is located at 3, comma, and then we're going to find out what the y value is. Notice how we took this x equals 3 from here, and we just brought it over and put it in place of the x column. You'll have to use the original formula and solve for your y value. So it'd be y equals open spot squared minus 6, and then an open spot, plus 4. You take the original equation and you put in the number 3, because for our axis of symmetry, we got 3. Do a little reducing down, we get y equals 9 minus 18 plus 4, or in other words, y equals -5. All right, so we'll put that right here. Okay, we can actually get quite a bit of the graph done now. We know the axis of symmetry is right down the middle, and we know the vertex is the high point or the low point on the graph. If we plot the point to the right 3, down 5, okay, that's where our vertex is. And then we make a dotted line on there. That's our axis of symmetry. Half of the parabola will be on one side and half on the other. And you also know that it goes up because it's a +1 for our A value here. Here's how you find a couple other spots. We'll make a table. And when we make that table, we're going to use some really easy numbers, some convenient numbers that go pretty quick overall. So this, go down here. Okay, and here we go. So when you make a t-table, go x and y. Use the number 0 to start off with. Now, when you plug 0 into the original equation up top, if you put a 0 right here and a 0 right here, all of this front part will equal 0. Do you guys see the number that's left over at the end? Be a 4. So 0, 4 would be the next point that you graph. That's left and right, 0, up, 1, 2, 3, 4. And because it's a mirror, you can move the dot over to the other side. So if it's located 3 to the left, you could count over 3 to the right. Just go across. And you know the parabola goes up, and you can make a U. Now, one thing I would do in class, and I would do it right now, but I'm running out of space here, is get one more point by plugging like the number 1 and coming up with another point so you can mirror it over. So it is nice to have 5 points instead of just, these 3 right here. If you do plug in 1 into the original formula, you'd come up with -1. And here's the points 1, -1. So it'd be to the right 1 and then down 1. So actually it worked really well. Then you mirror it over and there's the other one. So yeah, they fall right into place with this graph. Okay, so we just need this written down, the original formula, or the original equation. Just a couple of things before we even start. Since it's a negative, you know the graph is going to go down. And we can start off by doing the same thing as we did last time, which is the axis of symmetry, which is the formula -b/2a. Remember, it goes A, B, and C. So right now we're looking for a B value, which is 4, and your A value is -1. Reducing that down, you'd get -4 over -2, or in other words, when you divide it out, you get 2. The equation for your axis of symmetry would be then x equals 2. Now we're going to use that for a vertex. All right, so our vertex is a coordinate, and the coordinate is located at 2, comma, and we're going to find out what our y value is. Use the formula, y equals, keeping everything the same, plugging in the number we found for x, so we're going to plug in a 2. The first number we'd get is -4 plus 8 minus 2. Or in other words, y equals, that'd be 2. Plug that back up here. Okay, we can get a whole lot done now with just these 2 things. The first is the vertex. The vertex is located at 2, 2. Make a dotted line on that one, because that's the dead center of your graph. We need some extra points so we know where the graph is located. The extra points come from a t-table in which we use the easiest numbers we can think of, like 0 and, let's see if I can get that all on there. There we go. Like 0 and 1. Okay, so if you make a t-table with x and y and use the points like 0 and 1, here's what you'd get. When you plug in 0, you really just have to look at that last number on your original equation, which is -2, guys, right there. So -2 is the first one. If you plug in 1, you'd have to put it back into the original and then solve. So it'd look like this. I'm going to have to try to get off the side here. Y equals . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . All right, so the first part, you'd end up getting -1 plus 4 minus 2, or in other words, y equals 1. Okay, so let's get the first one done. Go to the graph and plot the point 0, -2. Now it's a parabola, so it's a mirror. The distance from that dotted line is over to the right 2, so I'm going to go 2 more to the right after that. Okay, so the black line is still in the center. And then the next point I can plot is 1, 1. So that's to the right 1, up 1. Now remember, it's a mirror again, so I just go across that black dotted line and put one over here. And there's the U that I'm looking for. It's upside down, like I said earlier. Connect the dots, and you're in good shape. Okay, there is a little bit more to this lesson that I would finish the second day, and that talks about throwing an object, but I'm going to skip that to keep this video short. So if you need to rewatch this video, please do. It's Sargent Silbernagel. This is section 9.2, and I hope everyone has a fantastic day.